These teachers are coming to Antarctica, one of the coldest, windiest, most desolate places on Earth.
It's absolutely incredible. Just stepping off the plane, see the mountains behind, and then just that way, just space as far as you can see.
But they're not coming to teach, or even for a holiday. They've come as part of a unique expedition to undertake fieldwork and report back what they find to their students at home. They've spent 18 months training and had to raise over £10,000 for the trip. This programme will follow their journey as they discover more about glaciology and learn about how to undertake fieldwork in some of the harshest conditions on the planet. Antarctica is the most southerly point of land on the globe. It covers an area larger than Australia. It's the coldest continent on the planet and is constantly covered in a layer of ice, holding the record for the lowest temperature ever recorded on the Earth's surface at -89 degrees centigrade. But although Antarctica is frozen and almost uninhabited, people still come here every year to undertake geography fieldwork.
Antarctica is a fantastic place for geography because there's so many sort of different things and different aspects to see. You know, glaciers, climate, geology, meteorology. You know, real examples of folding mountains where, you know, the rock strata is completely horizontal and then within sort of 10-15 metres, you know, it's completely vertical.
The teachers hope to be able to begin to assess the effects of global climate change on the ice by studying the melting of the Antarctic glaciers. A glacier is a huge sheet of ice, formed of compacted snow, which often fills whole valleys. Glaciers cover 10% of the Earth's surface, wherever summertime temperatures don't rise enough to melt the winter snow. In Antarctica, where temperatures rarely ever rise above freezing, there are some huge glaciers for the teachers to study. Three months before their expedition, the teachers visited a glacier in Norway.
That's impressive. Excellent.
They came to prepare for the harsh Antarctic conditions and to practice their procedures for their fieldwork.
It's a living textbook. Everything's here. It's sort of covering of gravel and dirt and moss, and it looks like it should be really grippy, but it's a tiny little covering. Underneath is just blue ice, really, really slippery.
While there, they took the opportunity to look at the structure and formation of the glacier. The glacier is constantly in motion, sliding down the valley. During the winter, ice builds in layers at the top on the main ice cap. Due to the sheer weight of the ice, over thousands of years the ice flows down the mountainside, often gouging huge valleys as it moves. The layers in the ice show the years of glacier growth, rather like a tree. During warmer weather, the ice melts, causing water to run down the glacier, forming a river at the bottom. This process of glacier formation is found in glaciers all over the world and can take tens or even hundreds of thousands of years to happen.
See if I can get it.
This glacier formed 18,000 years ago during the last ice age. Once the teachers have adapted to living on ice, they begin to test their fieldwork procedures.
Node 1, sterile sample.
Their project is looking at holes in the ice called cryoconite holes. These are caused by dust and dirt settling on the glacier. The dust absorbs the sun's heat. The warmed up particles then melt a hole down into the ice.
As more of these cryoconite holes develop, then they're going to create, essentially if they join together, they'll create rivers either on the surface of the glacier or beneath the glacier. And then when those rivers begin to form, then they lubricate the bottom of the glacier, which actually causes the whole thing to move much more quickly. So it's linked up with issues to do with climate change and global warming.
It is the abundance and distribution of these holes that they are measuring incrementally.
As geographers, we're interested in distributions and patterns, whether it's your population distribution across the country or across the world or things like that. So the idea of looking at the distribution of the cryoconite holes was to see, was there a pattern? Were they evenly distributed? Were they unevenly distributed? Were they in a very random pattern? Was it a very regular pattern?
By measuring the cryoconite hole distribution, they ultimately hope to be able to assess how much the glacier is melting and moving down the valley.
So these are all sterile, and basically what you've got to do is
One of the main reasons for being on the glacier prior to going to Antarctica is to test the equipment and procedures, and already problems are coming to light.
Here it's practical to open your coat and stuff your notebook down your jacket, but in Antarctica probably not. You're not going to be wanting to undo zips, anything. And here we're quite happy to waggle cameras around and keep them outside for a long time with no protection on. In Antarctica the battery will just drain instantly.
Now fully prepared, 3 months later in Antarctica, the teachers can finally begin their fieldwork proper. They look for cryoconite holes in the unexplored glaciers around the base camp.
If we find this stuff, and if we manage to get results back from it, we're doing something that hasn't been done before, or certainly, we're probably on a patch of ground here that no one's ever walked on before, let alone gone looking for scientific samples.
I reckon this piece of ice.
However, they find some difficulties they hadn't encountered in Norway.
those cryoconite holes, what you're looking for are snow-free areas. Now, because there's been a snowfall and there hasn't been much wind, there's a light sort of skim snow on top, so it makes the holes much harder to see. And then also just because the holes are frozen, you've got to do a lot of digging to get at them rather than just to take the water out. So it's much harder to actually get the cryoconite out of the holes.
Some big rocks on that side. What you got in there? Probably gravelly stuff in the middle.
Sometimes it wasn't very clear what was buried underneath the ice. Was it just a huge big rock, or was it actually the sort of cryoconite, which is a sort of much finer sort of dust? I think sort of Norway made it seem fairly easy, and in reality it was much more difficult in Antarctica.
The frozen holes also make the teachers reconsider their procedures for obtaining scientifically useful samples.
It's important when you're doing proper scientific research not to contaminate your samples. So obviously if you're hacking at it with a big ice axe, then you've got to be quite careful about what you're hacking away at.
To increase their chances of discovering the elusive cryoconite holes, the teachers go deeper into the mountains. Now, 60 miles from base camp, they take everything they're going to need with them for 3 weeks in the mountains.
Just wanted to give you a quick tour of our campsite here. These are our tents lined up beautifully, and what we've managed to create is somewhere where you can go to the toilet comfortably. It's got a beautiful view, toilet roll holder, that's obviously where the poo goes, in there. And it's a beautiful igloo.
The teachers begin to look for cryoconite holes in the new area and find the Antarctic landscape a fascinating place for studying geography.
The brilliant things we noticed when we were there was the sheer exposure of the rocks. So for a geologist it's absolute heaven, because where the rocks appear above the ice you see everything. There's no vegetation, nothing to get in the way. So it's a very sort of clear environment to do science in.
The storms in Antarctica can be extreme, with 80-mile-an-hour winds, low visibility and freezing temperatures. When one hits the camp, the weather is so bad that the teachers can't even go out of their tents.
Pretty much throughout the night and all day today, we've had winds that have been gusting up to about 30 knots. It's meant lots of digging out of the tent, and it's meant an awful lot of noise and rattling of the tent through the night and through the day.
Can't have a wash. Everything smells. So it's just a bit.
Once the weather clears, the teachers set off to find some cryoconite holes. However, the storm has made their job even harder.
I was looking for sort of blue ice areas, and there weren't many areas that we could see that were, except for, I suppose, a large bit down at the bottom of the glacier, which looked quite close, but in reality it was a 5-kilometre ski away. And then when we had skied all that way, actually there wasn't really that much good stuff there. And again, because there'd been quite a lot of snow, a lot of it was covered over. In terms of the sort of size and scale of Antarctica, it makes it very difficult to actually do science, because from a safety point of view, you can't go too far away from your camp.
In a final attempt to find some cryoconite holes, the team haul their kit to another glacier to try and find some clear ice. And finally, they think they find what they've been looking for.
Have you got whatever you're putting it in there?
Cryoconite samples.
Not completely confident that they're cryoconite. The idea of cryoconite is you get sort of really fine sort of sediment. So I suppose all I can do is just, take it back and see what's what. But I suppose, something was better than nothing at all. So that was really positive. So yeah, all in all, it's been quite a good day.
With a measure of success for the project, the teachers strike camp and begin the 40-mile haul with all their kit back to base camp. While they walk, they have a chance to think about the ecological footprint they've made on Antarctica during their time there.
Our biggest impact was actually getting to Antarctica in terms of the flight and the sort of global CO2 emissions. Actually, when I looked at how much rubbish we generated each day, it was very small in comparison to what I generated when I was back in the UK. We were actually environmentally very sort of sustainable in terms of what we were doing. The fact that we had to collect all our poo and things like that and bring that out of Antarctica, made you sort of appreciate what a pristine place it is and why it's important to actually keep it like that.
The teachers arrive back at base camp and begin the long trip home.
It's really nice to be back. It's been quite a long journey back, but I think everybody's really sort of glad to see friends and family, get a lot of really dirty washing sorted out.
But the hard work isn't over. On their return, they need to collate and analyse their data. One of the teachers visits Sheffield University, where they begin analysis of the cryoconite holes they found in Antarctica.
So that's clearly inorganic debris there.
The data will be put on file at the university, so when scientists return to Antarctica, they can use the teachers' data to assess how much the glacier has melted and moved over time. This will help them to understand the impacts of global climate change on the Antarctic ice. The teachers back in their schools in Britain will never forget their time in Antarctica. And they hope that their data will contribute to our knowledge of the geography of the region and of the world as a whole.